He was one of the leading lights of the revolution which came about in atomic physics.
Very, very common man. In fact, he was common as an old shoe.
You stood in awe of him, and yet you felt relaxed with him.
He wanted to do something really exciting and outstanding and out of the ordinary, either buy a car or get a wife.
Among his students, 3 have since received a Nobel Prize.
He could often be mistaken for a janitor.
One of the major purposes of his life was to make things clear, and he made them clear to himself, and he made them clear to others.
At age 45, a distinguished American scientist. At age 5, the youngest of 3 children in the family of a state railway official in Rome. At age 9, a schoolboy with an enormous appetite for books. At age 17, ready to begin an extraordinary career. Fermi attended the Scuola Normale in Pisa, a famous school for gifted students. Quantum physics was new then and had not yet reached the classroom. Fermi had to study on his own. To combat the frigid cold of the ancient buildings during the winter, he studied with a crock of burning charcoal on his lap. They still tell a story about him there. One day, the problem in chemistry lab was to analyze a mixture of salts. Fermi thought of a shortcut. He organized his friends, and they found a catalog of school supplies, and with a microscope from the physics department, they quickly identified the separate ingredients of the mixture by their color, their crystal structure, and so on. Somehow, Fermi's whole life work is summarized in this story. His ingenuity, his simplicity, his ability to organize teams, his high spirit, and his habit of getting the right answer by some straightforward shortcut. The time had come to leave Pisa and his friends to study quantum physics at a university where active work in the field was going on. The university at Göttingen in Germany was a center of brilliant activity, but Fermi felt discouraged by the formal and cold atmosphere. He moved on to Leiden in Holland, and there found a warm and enthusiastic teacher, Paul Ehrenfest, who instantly recognized Fermi's potentials and restored his self-confidence. A distinguished physicist himself, Ehrenfest's great ability as a teacher was to prove an example for Fermi. They became good friends. In 1925, Fermi moved to Florence. He became a lecturer at the university where Galileo had worked 300 years before. Here, Fermi followed a pattern which was to be lifelong. Unlike many scientists who specialize in either experiment or theory, he worked with equal zest in both. In 1926, he worked out a new mathematical model for the behavior of gases. His findings, now known as Fermi statistics, brought him international attention and a professorship at the University of Rome. Rome shared some of the mood of the 20s, and Fermi enjoyed himself. In play as in work, he was more interested in results than in formal niceties of style. With his primitive dog paddle, he could swim for miles. His knowledge of cars was slight but effective. He was very much aware of girls, one in particular, Laura Capon.
I was a student at university, and he was teaching already. When somehow we started meeting at a certain corner to get on the streetcar. Nobody said, let's meet, you see, but we started meeting more and more often. I remember trying to teach him to dance. Somehow I always had the poorest dancer in those times, so it didn't matter very much if Enrico didn't feel the rhythm. Fermi had always said that he wanted to do something really exciting and outstanding, either buy a car or get a wife. So when he bought a car, I was a little disappointed, although I really didn't have any ideas of getting married. But then he was more extravagant than he thought himself he could be, and so he got both a car and a wife. I remember a sense of being completely dazed, not even knowing whether he had asked me to marry him or whether he was posing the theoretical question of what would happen if I got married to somebody and he at the same time would get married to somebody else.
They married each other in July 1928. An honored guest was Corbino, prominent physicist at the University of Rome. Corbino had decided to bring together a lively group of young scientists, with Fermi the cornerstone of a new school of physics. The group became known in time as Corbino's Boys. For the next 12 years, they were to join an extraordinary accomplishment, as well as simple camaraderie. They invented elaborate jokes. Fermi, the ever-reliable authority on all matters of physics, was dubbed the Pope. Rossetti was the Cardinal Vicar. And Emilio Segre, who it is said once drove his fist through a desk in a fit of temper, was named after the mythical creature with eyes of fire, the basilisk. And there was the outdoor life, always a passion of Fermi's. He wasn't a particularly good skier, but he was strong and very competitive. And whether it was skiing or hiking or any game, or physics itself, he liked to be first. At 27, Fermi was made a member of the Italian Academy. He now had the official title of Excellency. But he didn't care much for ceremony or for the robes of office, which had cost him 3.5 months' salary. In the world of physics, rather than here, he valued recognition. Physics was undergoing a sudden, exciting growth. The basis had been laid by Max Planck, who in 1900 had proposed that the energy of atoms could change only in definite lumps, or quanta. Albert Einstein had extended Planck's ideas and claimed that the energy of light itself exists only in quanta. Ernest Rutherford had found the nucleus of the atom. Niels Bohr had shown how to bring all these findings together to build models of atoms that began to explain their emission of light and their chemical behavior. Now, in the late 1920s, the physicists felt that the remaining puzzles in quantum physics were at last yielding solutions. A series of conferences were organized. Each was a sort of family affair. Everyone knew everyone else. All the important physicists of that period could still have been gathered in one large room or on one small excursion boat. In this atmosphere, the latest theories and experiments and speculations were discussed and debated. Fermi's growing scientific achievements and his gift for simple and clear communication of ideas had already won him a secure place in this lively family of physicists.
I first met him in Zurich. It must have been early 1929. Oppenheimer was there at the same time. I first met him. There was a international conference which was arranged, a very significant one at that time, and Fermi came, and I first really got to talk to him more or less readily, and one liked him immediately. And he had just then done a paper in which, in a few pages, had done independently something which was a very great and large paper by Heisenberg and Pauli. His was simpler and had, many people thought, greater elegance, and this was on quantum electrodynamics.
In Rome, Fermi and his group worked in the University Physics Building. As always, Fermi combined teaching with his work in both theory and experiment. But perhaps his most widely noted contribution in the early 30s was Fermi's theory of beta decay. The puzzle was that in the emission from radioactive materials, Most beta rays came out with far less energy than predicted. If the energy is conserved, something must carry the missing energy. Fermi's theory included a suggestion made several years earlier by Pauli that the missing energy was carried off by a chargeless particle, which had not yet been observed. He called this hypothetical particle the neutrino, little neutral one. Fermi's ideas attracted a good deal of interest, and visitors of the statue of Niels Bohr began to take note of him. In 1931, Fermi's group helped organize an international physics meeting in Rome. To it came a group of notable scientists. In this university lab building, Fermi's team had decided that the most interesting new work would be the physics of the nucleus. But their resources were limited. A Geiger counter was a rare instrument then, so they had to learn to build one. They had to borrow a radium source. And so, without frills or fanfare, they began on a road that led directly to the atomic age. Camaldi, Fermi's first student and later his collaborator, recalls,
"At the beginning of 1934, we received from Paris the information that the Joliot had succeeded very recently to produce a few radioactive bodies, artificial radioactive bodies, by bombarding light elements with alpha particles. And Fermi thought immediately that the neutrons should be a much more efficient agent to produce new radioactive bodies than the alpha particles, since they don't have an electric charge. He started immediately to bombard all light elements with the neutrons produced by this source. We found in particular that if we had irradiate our piece of silver with the source inside or outside a certain lead protection for ourselves for the radiation emitted from the source, the result was different. We found also that the activation of this piece of silver was different according whether the sample was irradiated on a marble table or on a wood table that was nearby. So we were rather puzzled about this result. And our friend Rasetti, he was very critical towards us. He treated us as a young physicist, not very careful in doing measurement, and he started to say, well, you do something wrong. And we were very offended, and we protested, say, no, we do our measurement very well, but Rasetti insisted on that. At a certain point, Fermi understood that probably the effect was true, in the sense that the presence of lead, or maybe of other material in the vicinity of the source and the detector could change the conditions of activation.
how could neutrons produced with the aid of radium sources, such as those contained in the long glass tubes here, produce such puzzling effects? Fermi had guessed that it was due to those neutrons that had been scattered back from the table and from other objects that happened to be on it. These neutrons would be slowed down in the process of scattering, and it was these slow neutrons which could make the silver nucleus radioactive. To test the idea, Fermi let neutrons from the same source go through paraffin before reaching the silver. With a well-shielded Geiger counter, such as this one, Fermi tested whether the radioactivity caused in the silver was much increased. Sure enough, this is what happened. Now, paraffin, of course, contains hydrogen. Why not then try whether water also moderates the neutron's speed? And what better place than the little fountain outside the lab? Fermi's prediction proved to be correct. Water also helped the neutrons to activate the silver much more effectively. In high excitement, the group wrote up the results for publication that very night. A whole promising new field of physics had been opened up. Outside the laboratory, however, the world was becoming darker. Under Mussolini, all Italy was being pressed into a political mold which had a new name, fascism. Franco Rossetti tells how it reached into the lab.
Fermi was certainly a conservative person. His interest was so concentrated in physics that he had no strong feeling for politics. At that time, of course, in order to have a position in Italian universities, one practically had to be a member of the fascist party.
In the United States, starting around the turn of the century, physics had emerged from its adolescence with the achievements of Rowland, Gibbs, Millikan, and of course Michelson, America's first Nobel Prize physicist. At the University of California, Lawrence, along with his student Livingston, built the first cyclotrons. There were also outstanding theoreticians and teachers, and their work was attracting Europeans who came on visits to learn and to teach, among them Enrico Fermi, happy to discover America.
University of Michigan, in the middle 20s, started the summer schools for theoretical physics. A few prominent physicists were invited, 2, maybe 3, from abroad or from the United States. The lectures were few, fortunately. There was an enormous amount of time for getting together informally. Fermi was also a marvelous teacher in those days. His lectures were perfect. He made it all simple. He always knew what the essence was. He was never pompous. He never tried to make it more learned than was necessary.
Among other visitors to Michigan, Paul Ehrenfest, Fermi's friend and teacher from the days of Leiden. Europeans greatly enjoyed the holiday atmosphere of the summer school. Even Niels Bohr allowed himself to be jostled into position for a group photograph. After a lecture or a seminar, the work tables became picnic tables, and people could eat or watch the flamingos, or watch someone imitating the flamingos, or the bored lion. But in Europe, a cancer was spreading over mankind. The fascism of Germany, starting from hoodlumism, rose steadily to the murderous persecution of Jews and intellectuals. The luckiest ones escaped to America. 1935, Mussolini and his generals embroiled Italy in a war against Ethiopia. While Italy became absorbed with guns and troops, Fermi's group tried to keep going with its basic research work. They built a high-voltage generator for accelerating subatomic particles. As everywhere else, the apparatus of the physics lab was now growing bigger and began to lose some of its homemade look. By late 1938, Italian policy had become almost as fanatically racist as was Germany's, and Laura Fermi was Jewish.
There were a set of laws were passed in the summer that affected the Jews, but also that affected other people. They would have made the living in that country and raising our children in that country so bad that we decided to emigrate.
The right occasion suddenly presented itself. In December, Enrico Fermi was called to an impressive ceremony in Stockholm, Sweden. He had won the Nobel Prize in Physics for 1938 for his discovery of new radioactive substances produced by neutron bombardment. The great work he and his group had begun in 1934. Seated next to Fermi, the Nobel Prize winner in literature, Pearl Buck. As he was receiving his prize from King Gustav, few suspected that Fermi had quietly arranged to begin a new life. He had his family with him, and they would all go on to the United States. The Fermis arrived in New York in January 1939. He would be welcomed by I. Rabi and other leading American scientists, Arthur Compton and Harold Urey, Ernest Lawrence and Robert Oppenheimer. The Americans had good young physicists and equipment, and above all, a happy optimism. Now they were being joined by the best minds of Europe. It was an exciting combination.
What I think we had in this country, we had produced a large number of people who'd been brought up to a certain level and then needed some help, some leadership to get over the hump. And once they were over the hump, they were tremendous. People of my generation, more or less, that brought, in our respective institution, brought this over the hump. And we brought over the hump largely from attitudes and tastes and developments which we had learned in Europe. Not knowledge so much as attitudes, scientific culture, so to speak.
Also early in 1939, Niels Bohr arrived in New York to attend a physics conference in Washington. To his friends, he brought startling news, which literally changed their lives and the course of world history. Bohr had learned that 2 German scientists had discovered that the nucleus of a uranium atom could be split into 2 or more fragments, releasing a great amount of energy. Further, the splitting, later called fission, could be provoked by neutrons striking the nucleus. Fermi, then at Columbia, immediately saw the possibility of a chain reaction building up. As he explained it himself in a lecture given later,
if there is fission with very serious upset of the nuclear structure, it is not improbable that some neutrons will be evaporated. And if some neutrons are evaporated, then they might be more than 1, let's say for the sake of argument 2. And if they are more than 1, it may be that the 2 of them, for example, may each one cause a fission, and from that one sees, of course, the beginning of the chain reaction.
a fission chain reaction could release enormous amounts of energy. Uncontrolled, it might produce a tremendous explosion. With the clouds of war gathering, the terrible thought arose that the Germans would try to make such a fission bomb. A race with this specter began. A race without parallel in human history.